Good morning and good afternoon, everyone. My name is Brian Foster. I'm a content director here at PingCAP, and I'll be your MC for today's event. Query optimization is an integral part of any relational database management system. It's the how for processing all SQL requests to the database. And with TiDB, the goal is to allow your applications to scale without disruption, as you scale your system to heights only possible with distributed SQL architecture. In today's webinar, we're delighted to have PingCAP Optimizer Architect Terry Purcell share his 2 decades of insights to simplify the challenges behind query optimization, as well as reveal how TiDB's Optimizer is uniquely qualified to keep your distributed system running at massive scale. Terry has over 2 decades of experience in query optimization, including 10 years leading one of the most reliable cost-based optimizers in the industry. He's also contributed to more than 45 US patents, as well as countless webinars, white papers, articles, and conference presentations. Before we get started, please feel free to drop your questions directly in the chat window. We'll be sure to answer them during the Q&A portion at the end of the talk. And with that, I'd like to hand it over to Terry. Terry, the floor is yours.
Thank you very much, Brian. Checking you can hear me okay?
Yeah,
that's the
you're
first thing.
good.
Okay, we're good to go. Thank you, and great intro. I really appreciate it. You covered my first 30 seconds to a minute, so I could jump straight into the presentation. I really appreciate it. Thank you, Brian.
Sure thing. Sure thing.
So, query optimization, not a totally new topic. But again, Brian introduced it really well. So I'll jump straight into the presentation. Getting the technology working. So as Brian said, who am I? I'm Terry Purcell. I'm an architect here at PingCAP. I'm new to PingCAP. I've been here 6 months. So, don't be surprised if I don't know everything about TiDB database. Fortunately, we have a strong team here. I've been here 6 months and, I'm excited with what I see in TiDB at PingCAP. And I'm excited to bring my experience that I've learned, specifically in DB2. And, look, we won't be surprised. We're all a little molded or shaped by our experiences. And, DB2 for ZOS and the other legacy databases, I know in the industry, we look to those companies and think they're dinosaurs, they're old. But remember, they've been doing this relational database and then, SQL query optimization for over 40 years. So the established players like DB2, Oracle, SQL Server, they have an incredible amount of maturity to them. A lot of the problems we're trying to solve, in the newer architectures, some of those have been solved. But there's also new opportunities and new challenges in today's workloads that those architectures weren't faced with and haven't solved. So I'll talk about that a little bit as well. From a query optimization standpoint, I'm a cost model person. That's where my main focus has been. And I'll talk a little bit, of course, because that's my heritage. I'm going to talk a little bit why that's a critical part and often where there's an opportunity for databases to struggle. And also that's a differentiator when databases can improve that area. So I spent 10 years as the optimizer architect for DB2. I was there a total of 18 years. I started from the outside where I had customer experience using the database before joining IBM. I also had a really fun stint at MariaDB Expand, which was MariaDB's distributed SQL offering. There, we started out with a very, very small team, and my task was to build the team and basically productionize their query optimizer to take on the distributed SQL world. We unfortunately ran out of runway, and the company discontinued the Expand solution. So it was a great learning curve outside of the mature legacy database world. And some of those experiences I bring here as well. Now, I mentioned I'm a cost model person. All of my time has really been spent on the practical application in industry of the challenges around query optimization. So I don't have a PhD. but I rely on a lot of people that are incredibly smart and typically smarter than me. But you'll see with the more than 40 US patents for database search, we were really tasked with trying to solve real world customer problems, and that's where a lot of innovation comes. So I'm gonna maybe talk a little bit about areas you might not expect, especially when we get into query optimization, give you some perspectives to make you think about the challenges around query optimization. And then, as Brian said, talk about how TiDB can, is incredibly well positioned to address your scalability challenges from an application performance standpoint as your system scales. The first question is, can TiDB scale? Now, I can come up with a bunch of handy slides that someone else has given me to show you why the architecture scales, but this really is a query optimization presentation. I'm not going to spend too much time on how distributed SQL scales. I'm just going to leave it up to links to, and the words of customers. So, for example, here's a link and a quick summary from Flipkart. Now, this is their words about how they use TiDB to scale. And the link, either in the subject line, if you click on the own words part, or the link at the bottom of the slide, this is their blog. It's not our blog. It's not some sponsored blog. But it talks about how they have scaled, to 1 million, queries per second, which is pretty impressive. So it does demonstrate that, with TiDB, we can scale. At least that is their feeling. And they have proof of that. The other thing that was interesting for Flipkart, not just the scalability side, obviously they need to support their application and its scale to support their customers. But for them, it was also about meeting the scalability needs and also the compatibility with MySQL, so that their migration was relatively seamless or easy as possible. And again, they moved to TiDB, if you go and read their blog, because MySQL itself couldn't scale to the need of their applications. Another company, in their own words, is Pinterest. And again, they, their infrastructure, which if you look at the link at the bottom, again, another link that's an external link, not a PingCAP or TiDB sponsored link. They moved from HBase. And from a scalability perspective, they could see that they were unable to meet the needs of their application going forward for the next 3 to 5 years. So TiDB was their chosen solution, and it did, meet their scale, has met their scalability needs. So there's 2 customers. Looking at our website, there's another 34 customer stories. And it's exciting to me, actually, at PingCAP to have so many customer references. When I worked in IBM, our customers were very shy or very reserved, not wanting to publicly talk about their experiences. So it's really exciting to have these customer stories to share. And I encourage you to look at them, because this is customers in their words, not just us or our marketing talking about why we're the best database out there. So please go ahead and look at those customer stories. There's also a really cool article that's linked on our website, but it's a social media benchmark, and it was a collaboration with the company Meta, Facebook, and University of California, Berkeley. So that's a fun little read as well. I encourage you again to look at all of those. So just quickly, that's everyone else's words about can TiDB scale. They're saying we can, so I'm honestly going to trust them. They've been using it longer than I have. I've been here 6 months, and all of my time have been stuck, dug inside the query optimizer. All right, so I'm going to jump to query optimization, looking at the optimizer at a high level. Brian mentioned this, bit of a spoiler. The query optimizer, what is the role of the query optimizer? Now, firstly, query optimizer, maybe you've heard that term, maybe you haven't. The other term in the sort of little red bottom right of the screen Planner is another term that some databases use. The term planner or query planner is a common usage or term used for the optimizer in the Postgres world. So query optimizer planner, it's the same thing. It's the component of the database that is choosing the query plans or optimizing the query plans. As Brian was saying, it's the how to find the data part. So if you look at the whole premise of SQL in a relational database world, you know, a short quote from the original inventor, Ted Codd, of relational databases is the premise was of SQL, tell me what you want, not how to find it. So the what is the SQL, you know, you're writing, you know, you know, hopefully simpler than writing an application program for how to retrieve the data. And it's the query optimizer's role or job to determine how to retrieve that data. So that's, you know, again, very simple. What is the role of the query optimizer? This is a fun quote. I do like this quote. I've seen this, I've heard this multiple times. It's an anonymous quote. I stole it from someone else. And you know, I can't remember where I stole it from, but kudos to that person in their presentation for that as well. All right, so the quote is, you can read it, query optimization is not rocket science. When you flunk out of query optimization, we make you go build rockets. Very funny, right? Once I'm past the laughing part of it, you know, I look at it and it's a quote that's trying to say, look how smart we are, right? And I think, again, that's really funny. But to me, there's a slight negative connotation to this quote. A few aspects to this is, I don't want to give the message that query optimization is so complex that you can't understand it as a customer, or you as a, you know, as a student in college, that you shouldn't enter the world of query optimization because it's way too complex for you. You know, you have to be smarter than a rocket scientist. That to me is a false narrative. And actually, if you end up in the field of rocket science, you are probably in the wrong field of query optimization to begin with, because they are two distinctly different fields. To me, the real application of query optimization in a relational database management system is more about the practical application and not the scientific application. You know, so that's my take. But anyway, a funny quote. So I've included it here just for fun. All right. Given that, you know, I'm worried a little bit about the overcomplication, let's try and simplify the query optimizer. We'll try and put it into plain English. All right. So it's super oversimplified. So the PhDs in the audience might get upset with me that I'm making it too simple. The first step is typically about rewriting, transforming the query. So it's common in a query optimizer that there's this transformation process, query rewrite, query transformation. And it's typically to try and improve the predicate filtering to make it easier for the optimizer to apply the filtering at the right plan steps. The next one is considering all of the viable table join sequences, subqueries, joins, etc. The next, we're looking at mapping those plan steps to a physical executable step. And we'll go through a little bit more of this over the next few slides. For each of those plan steps, we have to evaluate the number of qualified rows that are processed in that plan step and the cost of that operation or processing those rows. And finally, you accumulate the costs and choose the lowest cost plan, right? So that's very much oversimplified. And the bullet at the bottom, or the little footnote, again, I really am oversimplifying it because going back to the prior slide, I don't really want to overcomplicate it. Ultimately, query optimization needs to be consumable, right? You need to, as a customer, be able to manage your query performance. And so overcomplicating it, doesn't help. oversimplifying it is maybe helping you at least understand at a high level the goals of the query optimizer and helping you do your job. All right, so this is an oversimplification. Some of these steps might be merged into one. They might be separated out further. They might be recursive, or even an individual step itself might be recursive. Often things like a transformation will fire a rule that rewrites a predicate a certain way or pushes it into an additional plan step that then triggers the opportunity for another rewrite. So some of these can be recursive, and as you go through additional joint sequences, you also introduce other opportunities. So again, very much oversimplified. All right, so challenges, risks of these, I'm going to start with, because I made a simple 5 steps. Challenges, risks of the, of the 5 steps, we'll start with the first 3. The first one, query rewrite. The left side bubble, from the DBMS perspective, query rewrites they're typically independent of the database itself. And they're typically well documented. There's a lot of literature out there about the different types of query rewrites that are common and implemented in most databases. So they're out there. From a user perspective on query rewrite, the user can often rewrite a query to simplify predicates themselves. Again, there's a lot of documented hints and tips, a lot of blogs out there, recommended rewrites, how to rewrite queries for your specific database. The next step, logical planning. There is some limited user opportunities there, like MySQL family has straight join. You can force certain table join sequences. Often left join enforces a join sequence. Won't go into that too much. But otherwise, the logical planning from a database perspective, it's very dependent on the framework that the DBMS has implemented. It may be the System R framework, Cascades, Starburst Optimizer. And so the plans or logical plans, joint sequences that the optimizer planner will consider are very dependent on the implementation that the database has chosen. Right? So then logical to physical is then mapping those logical choices, the logical plan steps, to the physical implementation. From a DBMS perspective, very dependent on the implementation. If you have a certain join sequence, you can't map that join to a hash join if your database has not implemented hash join, right? So you can only implement or map the logical to physical executable plans that are available in your database. From a user perspective, even logical to physical even includes mapping a logical table access to a physical index. Well, users can typically control index creation and the number of indexes available. Often you can control partitioning, clustering, things like that. So you can, as a user, often have influence over many of the physical choices that are available to the query optimizer. From my perspective, the challenges, risks of these these aspects of query optimization, they are well understood for the implementation. So this is thanks to years of ongoing academic research and that 40+ years of legacy database implementation. So for me, there's a little bit of rocket science in here, but a lot of it has already been done. So you don't need to be a rocket scientist anymore. And fortunately for me, I haven't had to be a rocket scientist. A lot of this, thanks to, again, academic research and the existing implementations, a lot of this stuff is already solved. Let's hit the later steps, 4 and 5. Now, the qualified rows and cost for each plan step, I'm calling out in red there. From a DBMS perspective, this can be hard, right? And I'll talk about that on the next slide. Now, the user can influence statistics collection, and that is a significant input to the optimizer with regards to qualified rows. The next one, bullet 5, accumulating the costs, choose the lowest cost plan. This is really easy. You're taking the cost of the first plan step plus the cost of the second plan step, and you just add them up. That's just math. That's really, really easy. So the accumulate cost part is not the difficult part in the query optimization. That's just math. But number 4 is where DBMSs typically struggle, and you end up relying a lot on hints. Now, hints are a valid solution, provided you understand why the hint is needed. But if you're using hints or needing hints to overcome a pervasive issue or a database level or table level issue, hinting an individual query is not really solving the problem. So now, I took this quote from another DB. I don't want to name the database, that wouldn't be fair, but this is a true cut and paste from some other database's documentation. And I've just, I've bolded and highlighted some areas. Now, this other database uses Postgres's cost-based optimizer, talks about, it's not perfect. Hey, look, honestly, most databases, the query optimizers do a good job. Nothing is perfect. And so, they're calling it out. This is not perfect. Interesting to me, they called out that the version of the planner that they use is suboptimal. That's an interesting thing to say. But anyway, then in green, they do talk about how row counts play a crucial role in calculating cost estimates. And I totally agree with that. But then the solution that they talk about, you could use the PG hint plan. Again, not really the message that I would like to give. But hey, this is a link. Oh, sorry, there's no link there. That would be unfair, but this is from another database's optimizer documentation. And I've just used the word another, right? I'm not saying what database that is. All right, so what is so hard about the qualified rows and cost? We're getting to the cost-based optimizer part of query optimization. So when people talk about, cost-based optimizer or CBO is, for the abbreviation, typically people think, you've got a cost-based optimizer that solves all of your woes. Not necessarily, but it is a good thing to have a cost-based optimizer. All relational databases typically have a cost-based optimizer. Rule-based optimization is many years ago, and is not the preferred way for choosing the effective or lowest cost plans. So what's hard about it? For each operation in the executable plan, I mentioned, we ultimately we are having to evaluate what is the operation's cost. So remember, we've mapped a logical plan step to a physical plan step. Now, that is a physically executable step in the database. So what is the cost of that step if I was to do it once? All right, that is obviously coded within the database. Then how many times am I doing it? Am I doing it 100 times, 1,000,000 times, once? So that's where the inputs come into it. So it's the number of rows that are processed in that step and what is the cost of one operation for that step. And then you basically, maybe I'm doing it 100 times multiplied by the cost. So that's for operation 1 plus the number of rows multiplied by operation number 2 cost. You add those up and you get a final cost. When you're comparing all of the available plan choices that the optimizer has considered, it's going to choose the lowest cost plan. If the total cost was wrong, then one or more of the inputs was wrong. So this is where it gets challenging. If I got an incorrect cost, it may actually not result in a poor plan, but if it did result in a poor plan, was it an incorrect input? Were the predicates combined incorrectly? Did we think the two predicates or multiple predicates were independent versus correlated? And that requires accurate statistics. Now that's the sort of the number of rows input, the input to that mathematical formula. Or maybe it's that your cost coefficients, the cost assigned to an individual plan step, maybe it has an incorrect bias. And I'll talk a little bit about that. But to come up with those cost coefficients, the cost of each operation, it does require significant effort from the query optimization team. Targeted hinted test case for scaling the operations, evaluating multiple workloads, and including hinting those operations to see how plans scale in comparison to each other, but also customer feedback based upon those issues. I want to call out in the bottom section here is, this cost calibration is really difficult for open source companies and really difficult for individual contributors. It's difficult for individual contributors because you're looking at a small piece of the code. You're not looking at, you're typically not building large scale workloads. You're not able to scale small to massive workloads to see how those cost coefficients or the optimizer scales. Very difficult for individual contributors, and also very difficult for open source implementations unless you have a strong company behind them. And if you read through what it requires to come up with those cost coefficients, you'll see why that is, right? So it's to me, that's obvious. It's not a criticism of individual contributors, but in TiDB, we don't get a lot of individual contributors. We really don't get any external contributors trying to adjust cost model formulas, etc. It's very difficult for an individual to do that. It does require a performance team, optimizer developer and an execution developer, and collaboration across those teams. The other part is you can improve the execution behavior, which is another part of the database. But the optimizer's job is to have a relative cost associated with that executable. So you can't do these in isolation. It's great that you improve the performance, but if the optimizer doesn't model that cost correctly, you can introduce an incorrect bias in your cost model. So again, this cannot be done in isolation, and it does require collaboration across teams. Now, are there solutions? Okay, so from your perspective, that's what this question is. Are there solutions? From your perspective, if you provide clarity of choices, then it is easier for the optimizer to differentiate. This is not to say that optimizers can't do their job. They really can. But the more competing choices you provide, either the more complex the query with filtering spread across multiple tables, the more indexes on each table that are candidate choices, the more clarity that you need to provide with statistics to help the optimizer differentiate the choices. So if you have a simpler query and fewer indexes, then that also provides clarity and choices. You don't have to be as diligent in giving the optimizer detailed information for it to differentiate. Now, relative current accurate statistics, like I implied, is a way to improve the clarity. Indexes targeted at the workload that are targeted at the most filtering. If you have complementary or overlapping indexes, again, you need clarity in statistics. But also, if you don't have efficient choices, like from an index perspective, having other efficient execution choices, if some choices aren't available, that's another benefit to improve the options for the query optimizer. And highlighting in red here is, we'll talk a little bit about the fact that sometimes we run into situations where the statistics are stale or missing. And what are the assumptions that the optimizer makes when that occurs? What I've seen in a lot of query optimizers is it's just some default. And if you think back to that quote in the another database paragraph that I'd shared, they made a comment that their optimizer is naive, just assumes this, right? Well, so you need some better solution than just a naive answer when you don't have something that's accurate, right? So again, that is a fault that some optimizers make. Another thing is, if sometimes choice results in the wrong choice, reducing the times you make a choice is actually a valid solution as well. Plan caching, plan management, they're viable solutions to improve plan selection by reducing the number of times you need to choose a new plan. And hints for specific queries, I rail on hints a little bit, but they are a valid option. You just shouldn't rely on them. Again, when I look at the DB2s, the Oracles, and SQL servers, those more very mature databases, Oracle, very much known for their reliance on hints. Okay, that to me is not a long-term viable solution, but hey, Oracle has been incredibly successful. From a query optimization standpoint, someone who spent a lot of time in DB2, it doesn't bring me joy to see, their sort of inferiority in query optimization. The other part, a call out here in red, are there solutions, a feedback loop to the optimizer developers to adjust the balances and assumptions, because customer workloads could expose some of these imbalances. And a key point about this too is, I mentioned in the open source world, often you may not have that feedback because you as the open source contributor are not the direct link to the customer or to the support of the customer. And also, if you're using an open source product like TiDB, but you're using the purchase version, you do have that link through support, through to the optimizer developer, where we're able to respond to your what you've exposed challenges in the database. If you're using the open source version, you may not have that direct link. Okay, so it's just, to me, that's just a logical answer to how we as optimizer developers need to use customer feedback to continually improve the query optimizer. And in some instances, that link is not there to optimizer developers. All right, so that's my optimizer high level, the challenges. And again, that's not just TiDB specific. It's just general, the way I see query optimization based upon my experiences. So the next thing to talk about is today's scalability challenges. Just throwing some things out there. Because to me, I talked quickly about the maturity of the DB2s, the Oracles of the world. Now, to me, they do have incredible maturity, but I will admit that at my time in DB2, we weren't faced with a lot of the rapid application deployment that we're seeing today and the larger volumes of data. We had very mature, reliable workloads and experienced DBAs that could manage the environment, right? So today is very different. The world of application deployment to me is very different. Larger data volumes, faster application deployment, rapid movement in data as in volume changes. But also customers are wanting to move away from that legacy database infrastructure and the vendor lock-in, and they are embracing open source. And to me, that is open source gives them an ability to avoid vendor lock-in. It gives them an ability to look at the code if they want, and it also gives them an opportunity to, fall back to an open source version if they're unhappy with that vendor. So, there's a lot of beneficial reasons to embrace open source. The other part about scale, what are some common database management features that are there for scale? I talked about the rapid movement of data. Automated statistics collection or auto-analyze is a common solution, right? To ensure that the database query optimizer is able to keep up with the movement in data. From my heritage in that legacy world, DBAs wanted to control more of that statistics collection. That is not as true today from obviously what I've observed. Query caching, I mentioned earlier, is a common solution to reduce plan choice or frequency of plan choice. SQL plan management is a solution that allows you to potentially lock in plans, fall back to a prior good plan if a new plan is not sufficient or not effective. Again, these are common solutions. I'll talk a little bit about TiDB's solution there. Sharding and partitioning are solutions for scale, often very necessary for scale. TiDB automatically shards by data range. There is data range sharding. There's range hash sharding. Some databases have one or the other. Some have both. I'm not really going to go too much into the differences, other than to say that for me, data range sharding, does allow easier scale out and scale in because it is less disruptive. But there's pros and cons to each, and obviously each database that has one will debate the benefits of theirs over the other. Partitioning is optional and complementary to sharding. TiDB has that available. We won't go into it today. Index advisor, index analysis is a common tool or capability that is also there to assist for, as I mentioned earlier about trying to provide, distinct choices for the query optimizer and targeted choices for the query optimizer. So an index advisor is a common solution that a database has. I'll talk a little bit about TiFlash as a differentiator for TiDB. All right, so getting towards the end, TiDB's strengths. So just trying to tie it in. Now, TiDB, to me, there are two main strengths, and it might surprise you that I'm only going to talk about two main things, because to me, query optimization is a large topic, but I do, the goal to me is really simplifying things for you, reducing the complexity and not overwhelming you, right? And helping you lay a good foundation and trust that the query optimizer is going to do its job majority of the time. The first one is TiDB's distribution-aware optimizer, including HTAP. We'll talk about that. Cross-database binding. I'll talk about that. To me, it's something incredibly cool, especially for software as a service or sort of the rapid application deployment that we're seeing. Two other important benefits that I'm not going to drill into. Auto-analyze, I just briefly mentioned because, I had highlighted that data is moving rapidly. So auto-analyze feature or an automatic statistics collection is a critical way to ensure that your optimizer is keeping up with those volume changes. And I've got a note there that many databases have a capability. So I'm not saying that that's a differentiator from other databases, but it is important to note that TiDB does have this capability, and it's on there by default. The other part that is very subtle, but I mentioned it, and I'm not going to drill too much into it again because we get too much in the weeds. But in the query optimizer, I mentioned another DB example where they talk about their naive estimates. Well, it is a critical area where optimizers can fall apart when information is not accurate, and again, data movement quickly, or not having the DBA skill, etc. You might not have all the information available. So the question is, what decisions does the optimizer make if there's information missing, right? And so things like there are certain application patterns where the data gets out of range quickly, right? So as data is moving over time, what are your estimates if the data is out of range and your statistics have not caught up? Another one is implied correlation. Do we think things are independent or correlated if we don't have information to confirm otherwise? So that is something that I've really worked hard with our very knowledgeable team about what we'd learned, through close collaboration with customers from my days in DB2. And again, I saw that in MariaDB, that a lot of the default decisions do not have that maturity. So that's something that we have been working on, and we're making very good progress. So the first one I talked about that I will highlight is TiDB's distributed data awareness in the optimizer. And I'm just at a high level, it's somewhat hard to explain, but the TiDB optimizer was built for a distributed database. This wasn't a single node implementation where we then added scalability. And I have seen that in some of the existing databases, the single node focus, some of the Postgres focus, MySQL focus, where they're trying to bolt on the awareness of the scale out or the distribution. And it's from a query optimization perspective, it's clunky. It's not naturally built into the query optimization processes. So in TiDB, again, it's subtle. It's hard to explain or give an example of. But with TiDB, it was built from the ground up as a distributed database, and its optimizer was aware of the distribution of the data. If we look at the HTAP optimization then as an extension to that, the HTAP optimization, our infrastructure allows the default of the TiKV or the key value store row-based traditional OLTP style infrastructure. You can also create copies of tables in the columnar store style implementation, so more of the analytical style processing. And we call that TiFlash, right? So it's they are independent nodes where there is again a copy or replicated copy of the underlying table data, and you can choose which tables are replicated to TiFlash. They're two separate storage and coprocessor engines. What's really cool to me, because DB2 had this capability, Oracle has the capability. In DB2, it was a full replication. So DB2 would send the entire query over to the columnar engine. In TiDB, we have the awareness and the capability to have part of the query executing on TiFlash and the other part on the key value store. And the query optimizer is aware of the cost associated with either and can choose TiFlash if available, just like an index might be available for an individual plan step. The other part about when it's executing on the TiFlash nodes, it gets the full power of a traditional MPP implementation, so a massively parallel processing implementation, which is common in those data warehouse applications. But what I will say about this HTAP, and we learned this in DB2's implementation, and I'm jumping to the bottom here, so sorry about that. So HTAP, yes, brings this promise of hybrid transactional analytical processing, but that some customers see the value of that. It was really a significant marketing focus, I don't know, maybe 10 years ago from Gartner. It resonated with some customers, but it didn't really penetrate the industry as a real, the approach didn't take off. But what we learned in DB2 was a lot of customers wanted to use this for workload separation. And to me, that is a critical opportunity in a scale out solution. So let me explain. I'll jump back up to the top of the screen. Indexes and queries can inhibit scalability, right? As you scale out, and you're throwing more queries at the system, longer running queries, consume more resources, and they can therefore, inhibit or take resources away from OLTP. So having that HTAP opportunity can allow you to have candidate queries be routed by the query optimizer to the analytical processing side, that the TiFlash, thus reducing the risk of negative impact to your OLTP workload. So as you scale, TiFlash can give you that separation and protection that longer running queries have minimal impact to your OLTP work. So it's not just queries that can impact scalability, indexes can impact scalability. I've seen in the Oracle world, Oracle migrations, DB2 migrations, it's common because they weren't built with these hybrid infrastructure. You might have 10, 20 indexes on a table. Indexes are there to support business logic, like enforcing uniqueness, primary key enforcement, and then primary key lookup for OLTP, highly selective lookups. But often indexes were created to support querying, right? But then, if you've got 10 or 20 indexes on a table, as you scale out and are trying to scale your inserts, and then those additional indexes can inhibit your scalability, right? So the HTAP implementation of TiFlash also creates an opportunity to reduce some of those query-based, the indexes that were there for querying, and to have them more focused, the indexes for the OLTP side of it. Okay, so that's, to me, a differentiator and a real opportunity to improve your scalability while still allowing a hybrid workload. Because it is true that a lot of OLTP applications, they're typically not doing heavyweight data warehousing, but there is some querying that's part of your OLTP workload. And so in the middle there, I mentioned, previously that most databases have an index advisor. Here's a link to our index advisor. It's a blog about our index advisor. Index advisors are often self-explanatory, but again, there's a blog there. I encourage you to look at that because index design itself can be challenging, especially as you try to scale your workload. When you get hundreds, thousands, tens of thousands of SQL statements or tens of thousands of objects, index creation and index management becomes very difficult for an individual human being. All right, this is going to actually be my last topic. So I talked about the benefit of TiFlash for scalability. The next one is about our plan management implementation. And I mentioned that plan management, caching, etc., are common solutions that databases have. I will say in my time at MariaDB Expand, which was a separate product from the core MariaDB, MariaDB and also MariaDB Expand didn't have a plan management solution. In DB2, it was critical for our customers. TiDB has, to me, a unique implementation. We call it binding. And what is unique about it is it allows you to hint an SQL statement. So this is micromanagement of SQL, which I'm against, but it leads into something bigger, where you can hint an SQL, and then you can actually bind the original SQL to that hinted SQL. So the example here, and it's say I'm hinting an SQL to say ignore this index because maybe I want a table scan for whatever reason. But maybe I can't change the original query, right? So I can't put that hint in the query. I can create a binding which will bind that query to that hint, such that when the database, the query optimizer, sees that SQL statement, it will replace that statement with the binding, right? So that's the premise of this binding. Now, so you can do it from that perspective of hinting an individual SQL, or you can take queries from the statement summary table, which is an externalized summary of queries that have been executing in your system. And you can create the binding from the existing plan digest. And the plan digest is a column, that's a value from that statement summary table. So you can cut and paste that into there. or create a set of queries that will generate bindings for you. Or you can enable the auto capture feature for a period of time, setting it to true, then false, such that it will create baseline capture baselines for bindings. So again, the implementation uses a hinting infrastructure. And so to me, that's unique. It's kind of cool if you see the ability that you can hint individual SQLs but not have to change the original SQL, but it also scales out to capturing larger workloads. What is also very cool, I talked about the faster application deployment, including software as a service, cloning to new schemas, new tenants. In that instance, often you're rapidly deploying the application and the tables start out empty, and then the database with its auto analyzer may take a little time to catch up, right? So, as you're loading data into the application, inserts are occurring, the optimizer may be making decisions on empty tables initially, right? So there can potentially be disruption in the early plan selection. TiDB's plan management has this cool feature that we call cross-database binding, where you can take bindings and you can copy them to another database, so to another schema. So it allows cloning. If you're cloning an application from one schema to another schema, you can also clone the bindings. And to me, that's an incredibly cool opportunity, which customers are using for rapid application deployment, especially in the SaaS style applications. You can see opportunities in future where we're looking into being able to clone, sort of export and import to other clusters. So you can see the opportunities here. So I do see this TiDB's plan management implementation using this binding as a very cool and unique way to address some of this rapid application deployment, especially when you are modeling from an existing copy of an application. So again, to me, this is incredibly cool for scalability. That, to me, the legacy databases didn't solve, at least in my lifetime. Okay, so to recap, the demands of today's applications, larger data volumes, distributed SQL we talked about, and in their customers' own words, that they're proof points that distributed SQL is meeting their scalability needs. More volatile, dramatic changes, data's moving more rapidly, also faster application deployment, including software as a service, customers moving away from the higher cost legacy databases. So the distributed SQL database, we have a differentiator, to me, TiKV, TiFlash. On the data is moving rapidly, like many other databases, we have auto-analyze capability to keep up. I also feel like we're doing a great job right now of smart defaults and assumptions when the information isn't fully baked. The cross-database binding for me is a very cool feature for faster application deployment. And ultimately, take that last bullet, a plug for us, if you're moving away from those legacy databases, or if you would appreciate the maturity and attention to that reliability scale that the legacy databases provide, who can you trust to do that, right? A little plug for TiDB open source. We are an open source database. There are the links to the TiDB database. That's the database layer. KV is the key value store, TiFlash, workload analyzer. And if you want to start experiencing TiDB serverless, please go ahead. There's the link.